So in our today's class, we are going to study the next concept is relative velocity. So basically, we are having this relative velocity in two ways. One is in one-dimensional motion, and another one is two-dimensional motion. So first, in our today's class, maximum will try to complete relative velocity in one-dimensional motion. So later we will discuss relative velocity in as well as two-dimensional motion. So now, before going to study this relative velocity or whatever it is, you can take relative acceleration or displacement or whatever it is. First, we need to go back to the class 9. So let us discuss what is that. So first of all, we are going to see relative motion or relative velocity in one dimension actually. Okay. So now, if I use instead of relative velocity, I can use acceleration also. So we are having relative acceleration. You can use relative displacement or relative distance also, or else simply I can say relative motion. So what do you mean by this relative motion? So let us understand that. Before going to understand this relative velocity and all, first of all, you might be studied in class 9. Class 9th chapter, first chapter in physics is motion. Is it yes or no, guys? All of you? Yes. So motion is our first chapter. You might be studied by the time motion and rest both are relative terms. So that is what is might be remembered from the class 9. And so a few of you, even I only taught you. So I can say both motion and as well as rest both are relative terms. So means in the sense of, so let us discuss one example so that you all understand very clearly. So you can see everybody here. For example, this is the surface of the earth. Now two persons are sitting on the bench. So let me take a bench now. Two persons are sitting on the bench. So this is the person one and this is the person two. Now let me take this person name is A and this person name is B. Now A is continuously seeing the B. Now you tell me with respect to A, with respect to A, B is in what? B is in motion or in rest. Everybody, with respect to A, B is in what? B is in state of, everybody, please respond. B is in state of rest. And if you take with respect to B, A is also in what, Pradosh? A is also state of rest. Is it clear? Understood, everybody? All of you? Yes or no? So with respect to A,
Yes.
B is in state of rest. With respect to B, A is in state of rest. So now let us understand, for example, now again the same earth I am taking. Same earth I am taking. Now the person A is went from the surface of the earth to, now only person B is sitting on the same bench on the same park. Now a person A went to the space and he is observing the person B from the sky. Now you tell me, or from the space. Now with respect to A, person B is in what? Everybody. With respect to A, person B is in what? B is in motion or B is in state of rest? Everybody? Yes, please.
Motion.
B is in state of motion. Of course. Why? Because as we all know, Earth is
Yes.
continuously, as we are here, if you notice it, both are lying in the same surface or different surface. Everybody. Same
Same surface.
surface. Understand? So, observer, if you consider A is the observer, A is observing the B from the same surface. And if B is the observer, B is also observing the A from the what surface? Everybody.
Same.
Same surface. So that is why with respect to A, B is in rest. With respect to B, A is in rest in the first case. But as soon as A reaches to the space, now as we know, B is sitting in the same park. Now we know all everybody. So Earth is revolving around the sun, and also it is revolve around itself also. Is it yes or no, guys? Rotate around itself also. So as we know, Earth is continuously in uniform acceleration. Continuously it will be in a motion. So that what will happen if observer A is seeing from the space, continuously the position B will changes. So that is why by that time I can say with respect to A, B is in state of motion or state of rest. Everybody,
Motion.
state of motion. Clear or not? All of you understood? Please respond.
Yes, sir.
Yes. Any doubt? Anybody can ask me. So this is very, very important concept. That's the reason I'm saying I'm stressing it this much time. Okay. So now let us take one more example so that you all understand. For example, so let me take a let me take a beautiful train. Now, for example, let me take two persons are sitting in that. Let me consider is a Palwan Express or some other thing which is going from ethics. Now, two persons are sitting in the same train and same compartment. Both are sitting side by side. Let me take this boy is A, this boy is B, and this boy is A. Now you tell me, with respect to A, B is in state of rest or state of motion? Everybody, yes, please. With respect to A, B is in what, guys? B is in state of, yes, please. B is
Rest.
in rest. Why? Of course, train is moving. Oh, I'm not saying that train is not moving. Train is moving. But what is happening here, Rudreswa? Both are in what? Both are in the same train. Yes or no?
Same
So
surface.
of course, train is moving, but they are in the same position. So if they are saying from the same surface, then with respect to A, B is in state of rest, and same way with respect to B, A is in also what? Pradosh? A is in also state
Rest.
of rest. Clear? Now, if you observe, for example, now C is the person who is standing on the platform. Observe very carefully. Now, train is passing in front of you. Now, you tell me if both A and B are the observers. A and B are our observer. Understand, Rudreswa? A and B are our observer. Now, if A and B is seeing the C, now you tell me with respect to A and B, C is in what? Everybody, C is in all of you
Motion.
motion. But actually, who is moving? C is moving or train is moving? Yes,
A and B.
A, B, and B. Train is
Mm.
moving, but as well as C is in standing in the state of rest, but with different surfaces. C is standing in the different surface, and A and B sitting in the different surface. Due to that, C is appears to be in what, guys? Everybody. C is an appears to be
Motion.
motion. So with respect to C, A and B in what, everybody? A and B also in what? All of you.
Motion.
So we mostly will experience this when we are traveling in the train. You might be noticed all the hills, mountains, and all is moving backward. All the buildings, people, everybody, they are moving backward when we are traveling in the train. Is it yes or no? Will you all experience it or not? Yes or no, guys?
Yes.
So have you noticed it? So from the position where we are seeing, that is what the reference point we used to call as. From the reference point or origin, the same object is appears to be in state of motion, or same object is appears to be in state of rest. Is it yes or no? Everybody? All of you?
Yes, sir.
So if one object, if I'm seeing from the different position, it may appears to be in state of motion. From other different position, it may appears to be in what position? Everybody? State of motion. So which is appears to be in state of rest, may appears to be in state of motion if I am seeing from the different reference point. Yes or no, Pradosh? Do you all understand? All of you?
Yes, sir.
So that is what we used to call as relative. Relative means, all of you remember, relative means with respect to reference point. So that is what we used to call as frame of reference. What we used to call? All of you? Frame of reference, or we can say reference point. Reference point. Clear? All of you understood or not, Pradosh? So this reference point only we used to call as observer. So based upon the position of the observer, the same object maybe appears to be in state of motion, or same object is appears to be in state of what? State of rest. Clear, everybody? So that is why I can conclude both motion and rest, both are what terms? Everybody? Motion and rest both are related.
Relative.
Understand? Rudreswar, are you clear? This is actually class 9th introduction of motion. Now, are you clear, everybody? What is important? Relative frame of reference. Relative means frame of reference. And you remember, there is no kind of absolute rest and absolute motion. Are you understand, everybody? Do not exist in the universe. Clear, Pradosh?
Sir.
In the universe, it will be depend on what? Either I can say, for example, Pradosh will say this object is said to be in motion. Rudreshwar will say this object is said to be in rest. How you can say? Maybe Pradosh is seeing from the different point and Rudreshwar is seeing from other different point. So based upon their frame of reference, everything is changing. Is it yes or no, guys? All of you understood?
Yes, sir.
Yes. Clear? Yeah, that is what you have to remember that. Clear, everybody? Yes or no?
Yes, sir.
So based upon when we are seeing from the particular point, that is what based upon observer's view, observer's point of view, either we can say the object is said to be in motion or the object is said to be rest. So that is what now we are going to see. We are going to find in this class, we are going to find how to calculate relative velocity with respect to ground, with respect to another person, etc., etc., and as well as relative acceleration, displacement, and as well as simply I can say relative motion also. So hope you all understood what is relative motion. Now from here, if you will understand, then we will proceed further. Is it okay, guys? Clear, all of you? Yes, please. Now, so observe very carefully here. Let me take now observer is here. I will try to draw beautifully. You try to make it. So this is the name of the person is B and he is my observer. What is that, everybody? He is what? He is my observer. Clear, all of you? Now, another person who is traveling in a trolley. Clear, everybody? Another person who is traveling in a where? Who is traveling in a trolley. So he is standing on the trolley, above the trolley. Now the trolley is moving with a 10 meter per second. So observe very carefully. Who is our observer here? Who is our frame of reference?
B.
B. Clear? So now observe very carefully with respect to B. Now I want to find velocity of A with respect to B. Is it okay, Rudreshwar? Pradosh, can you able to hear me? Velocity of A with respect to B. So who is our reference point here? Who is our reference point?
B.
If you have any doubt, please be very careful. I will be going very, very clearly. This is the most important concept. Next concept, two-dimensional, if you want to understand, this is very important. So with respect to A, sorry, the relative velocity of A, V means what? Everybody? V means what? Relative
Reference.
velocity. Clear? Relative velocity of A with respect to whom, guys? B is equals to velocity of A minus velocity of B. So can you tell me now what is the velocity of A, everybody? Velocity of A is what? 10 meter per second, and velocity of B, he is in rest. So what is the velocity of him, everybody? Yes, please. 0, because he is standing, he is observing just. So 0. So which is equals to what is the relative velocity of A with respect to B, everybody?
10 meter per second.
10 meter per second. Understand, Laksha? Clear? Clear?
Yes.
No. So let me consider another case. This is anybody having any doubt, you can ask me. It's always late. I don't like this. What you will understand. Base introduction is very important more than a concept. That is what is needed for me. So now, let me take now, this is another trolley where the people are traveling. Okay. Now, both A and B, let me take Mr. Pradosh and as well as Mr. Rudreshwar, both are traveling in a trolley. Now you tell me, now B is my observer. Who is my observer? Everybody? Who is my observer? B is my observer. Now you tell me, with respect to B, of course, this trolley is traveling 10 meter per second. Now, the relative velocity of A with respect to B is equals to how much? Anybody? So, relative velocity of A minus relative velocity of B. So, how much it is, guys? Everybody? Can you tell
0.
me? 0. Why? Both are in the what?
Same, sir.
Same.
Correct.
Clear? Brothers, can you getting what I am saying? Relative velocity.
Yes.
So 10 minus 10, which is equals to 0 meter per second. Any doubt, anybody can ask me this. Clear? Yes, this is Sai Karthik. Understood? Samaya? No response, no use. Mania? Ishali? I don't know what you will understand. That's fine. Clear, everybody? Understood or not? Okay, that is what. Next, same way. So observe very carefully. Observer B, observer is our B. He is at the ground. Now, a person is traveling in a trolley with the acceleration. With what actually? Everybody? With the acceleration of 1 meter per second square. That is the person who is standing on the trolley. Now you tell me, What is the acceleration of relative acceleration of A with respect to B is equals to everybody. Relative acceleration of A with respect to B is equals to fastly. What will happen? Acceleration of A minus acceleration of what? B. So what is the acceleration of A? 1 minus acceleration of B is 0. So what is the relative acceleration of A with respect to B? Everybody. 1 meter per second square. Clear?
Seconds per.
Understand? Next. Let me take now another trolley where both A and B traveling with on the same trolley, and trolley is moving with the same 1 meter per second square. Of course, both A and as well as B is there. Now, B is my observer. Now tell me, with respect to with respect to B, what is the relative acceleration of A? Everybody. What is the relative acceleration? All of you. Acceleration of A minus acceleration of B, which is equals to 1 minus 1. So what is the relative acceleration of A with respect to B? Everybody. 0 meter per second. Understand? Everybody? Laksha? Ishali?
Yes, sir.
That is what. Now, if you notice it, all of you. So let me take for example. Now, first let me discuss about this case, all of you. See, check it everybody carefully, brothers. Now, B started seeing at time t is equals to 0. Now time t is equals to 1, time t is equals to 2, time t is equals to 3 seconds. Like that, keep on. Is it acceleration of A with respect to B is going to change or not going to change? I thought that's what my question. Everybody.
Not change.
Not going to change. Now here also, time t is equals to 0, time t is equals to 1, time t is equals to 2, like that, time t is equals to n seconds. So he's keep on observing. Is it acceleration of A with respect to B? Is it going to change? Anybody? 5 seconds, 10 seconds, 15 seconds, 20 seconds, whatever it is it going to change? Unless his position change, is it going to change any kind of acceleration? Anybody's? All of you? Please respond. No. So
No, sir.
from that, can I say even velocity? Let us go back to the velocity now. So I will say observer B is observing t equals to 1, t equals to 10 seconds, t equals to 20 seconds, t equals to 30 seconds, 40 seconds, 50 seconds. Is it the velocity of A is going to change even though he is continuously observing? Everybody? Yes, please. No. Yes or no? Same way here also. Continuously observer B is observing the A, even though they are in the same, unless the position changes, they are in same time. Even though they observe after 10 seconds, 20 seconds also, the relative velocity is how much? Relative velocity of A with respect to B is equals to how much? Everybody? It is equals to, yes, please, 0. Clear?
0.
Understand? So means in the sense of time is a dependent on frame of reference, or time is not dependent on time of a frame of reference? Everybody?
Not dependent.
Yes, please. Very, very important. So what is that? All of you. Time is
Not dependent.
time
Not dependent
not
on.
depend. Understanding? Depend on frame of reference. Is it okay, guys? Are you all understand?
Yes, sir.
Any
Yes,
doubt?
sir.
Everyone, please respond. Clear? Time is not depend on frame of reference. Is it okay, guys? Hope you all understood.
Yes, sir.
That is what. Now,
Yes, sir.
next, if you will understand this, this is what the concept. I hope you all are clear. Now, let us proceed. Question number 1. Okay. So please be very careful. Based upon the frame of reference, from where the observer is observing, maybe the object is same object is appears to be in motion, or same object is appears to be in state of what? Everybody? State of rest. So those who join late, kindly watch this introduction. Unless you watch the introduction, you cannot understand what do you mean by frame of reference. Pradosh, any doubt in frame of reference? Let me know. Laksha?
No, sir.
That is. So let us take now. Yeah, let us take on the same surface. All of you observe very carefully. On the same surface, observe somebody name called as B. So B is traveling with a velocity 20 meter per second. What is the velocity of B? Everybody? 20 meter per second. And another body A who is traveling with a 10 meter per second. Do you all understand, everybody? Yes, please. All of you observe 10 meter per second. All of you understanding? Now, basically, let us discuss who is traveling faster. General language. I want to discuss general language. Who is fast? Who is discussing? Who is traveling faster? General language. Let us discuss sometime so that we will go inside the question. Please respond, all of you. Yes, please. For example, B seeing A. Let me say this one. B seeing the A. Now you tell me when B is observing the A, B is our observer. So now you tell me A is appears to be coming towards the B or going away from the B. Anybody? B seeing the A. Now you tell me A is appears to be coming towards the B or going away from the B. I want to know. Yes, please.
Wave towards.
Yes, please. All of you. Please respond. B is appears to be.
Away.
Yeah, when B is, Pradosh, be very careful. When B is our
Sir,
observer,
towards.
B is observing the A, Pradosh. So now you tell me A is
observe.
coming towards the B or going away from the B. Yes, please. Others don't know.
Sir, towards.
Yeah, towards. Because why? Who is traveling faster here? Who is traveling
B
faster?
is faster.
B. Actually, B is moving closer to the A. But who is our observer here? B is our observer. So A is appears to be coming what? Coming closer or moving faster? Moving far. Coming closer. Are you clear, everybody? Now, A is my observer. A is seeing backward. A is seeing backward. Now you tell me B is appears to be coming closer to A or moving far away from the A? B is appears. Yes, please. All of you. B is coming appears to be or moving far away? Everybody, please respond. Nobody respond.
Closer.
Moving closer. Yes or no? But you see, B will feel A is coming in this direction. Yes or no, guys? Will you all accept it? B will feel that A is coming in this direction. Yes, Rudreshwa?
Yes, sir.
Yes. And A will feel B is coming in which direction? Like this direction. Is it right or wrong? Laksha? Pradosh, any doubt, Pradosh? Can I explain once again? Yes? Please respond.
No, sir.
Yeah. So observe very carefully. B is faster here and A is slower. Now, for example, see, now one boy is running here in a forward direction. Another boy is running very faster in the back of him. Now you tell me when he is the B and he is the A. Now B is running fast, runs faster than A. Now you tell me when B is observing the A, tell me A is appears to be coming towards to the B or going away from the B. Anybody's? That's what the question. Simple. Yes, please. Actually, B is moving to the A, but if B is our observer, A is appears to be coming towards to him. Yes or no, guys?
Yes, sir.
Laksha, understood? Yes. Now, A is my observer. If A observes, B appears to be coming what? Closer, as it is B running very faster. Yes or no, guys? Please respond. All of you?
Yes, sir.
Yeah.
Yes, sir.
Now, always forward will take positive or negative? Positive. And opposite side will take it what? Negative. Yeah. So if B is our observer, then A appears to be coming how many meter per second backward? Let us calculate it. He is coming some speed towards to B in a backward direction. Is it yes or no? Everybody? Understood, Pradosh?
Yes, sir.
That is what. So that is the first case. Write it. When B observes observes A, then speed of A as seen by B. How it will be? Backward or forward? Speed of A by seen by B. Is it backward or forward direction? It is appears to be. Yes, please. A is appears to be coming what direction? Backward or forward? Backward. Yes or no? So let us find who is our observer here. Check it, everybody. Who is our observer? B. So relative velocity of A with respect to B, which is equals to what is the formula? Respond. Relative velocity of A minus relative velocity of B. Is it right or wrong? Yes?
Yes, sir.
This velocity of A is what? With respect to whom? With respect to whom?
Ground.
Everybody. Velocity of B is with respect to whom, guys? With respect to ground. Understand, everybody?
Ground.
Now I will say
Yes, sir.
body A is traveling 10 meter per second. With respect to whom? With respect to
Ground.
ground. So I will put here AG. So what is AG means? Velocity of A with respect to ground minus velocity of B with respect to ground. So can you tell me what is that? Velocity of A with respect to ground is 10 minus
Minus.
velocity of B with respect to ground is 20. So when B is our observer, what is the relative velocity of A? Plus 10 or minus 10?
Minus 10 meter.
Minus 10 means he is appears to be moving forward or backward? Backward direction. Clear? Yes, but actually who is moving there? Who is moving? B is moving. Yes or no? B is moving towards the A. Clear everybody? Understood?
Yes, sir.
Yeah. Now, next. If speed of B as seen by A, then what will happen? Now A is our observer. A is seeing backward and observing B. So speed of B as seen by A. So can you tell me now?
10 meter per second.
As seen by A. What will happen? All of you. So now with respect to whom? Relative velocity of B with respect to A, which is equals to what will happen? Relative velocity, velocity of B with respect to whom, Ra? Ground minus
Ground.
velocity of
Relative
A with
velocity
respect
A.
to ground. So which is equals to 20 minus 10, which is equals to how much, guys?
10 meter per second.
10 meter per second. So if A observes B, B is appears to be coming forward direction. So that is why it is plus 10. Clear? All of you. And this is B observes A and A is appears to be coming reverse direction. That is why it is minus 10. Hope you all very understood. Any doubt anybody can ask. Clear? Yes?
Yes, sir.
Yeah. So this is what the first question. Any doubt anybody can ask. Pradosh? Understood, Pradosh?
Yes, sir.
Very important, Pradosh. That is why it is. Next, question number 2. If the concept is clear, everything is very simple. If the concept is not clear, it's very tough. So hope you all are understanding. Now, let us see question number 2. So let me take now, one trolley is traveling a trolley actually. So, or else you can take some bus or something. So trolley A is traveling forward, trolley B is traveling forward direction with 10 meter per second. How many meter per second, everybody? 10 meter per second. Next, trolley B is coming opposite to the trolley A. Opposite. Be very careful. Same direction or opposite direction? Opposite direction. Understand? Opposite direction with 30 meter per second. How much it is? All of you? 30 meter per second. Same direction or opposite direction? Opposite direction. Mr. Sai Gardik, are you understanding? Manya and Samya, no response. Leave it, please. I don't want anything. Those who are studying, 5 members also enough. Are you understand or not? I don't know. Notes taking or not? I don't know. No response at all. No question you say answer. So now, let it be. This is what my question. So please, all of you tell me. I want now, B is my observer and I want to find the velocity of A. So can you tell me now? Sorry. So B, I want to find the velocity of B, relative velocity of B when seen by A. So A is my observer first. So can you tell me what will happen? Relative velocity of B with respect to A, which is equals to how much? Fastly tell me. Relative velocity of B with respect to A is equals to what will come? Velocity of B with respect to ground. Sorry, with respect to trolley now. Yes or no, Pradosh? Not a ground. They are not running in the ground. Where they are running? Trolley. So trolley means here will come. Ground will come or trolley will come? Trolley will come. Clear? Yes. So that is what. So minus velocity of A with respect to trolley. So which is equals to how much, guys? When seen by A. Understanding? So who is our observer? Seen by A means who is our observer? A or B? A or B? Yes, please. A is our observer and B is relative velocity we are finding. So how much it will come? 10 minus and opposite C. If I take this is plus, forward direction. Backward direction is what? Minus or plus? Minus, opposite. So minus of minus 30. So which is equals to, so you tell me, so B appears to be coming, how much meter per second? Everybody? Yes, please. 40 meter per second towards to the A. Clear? Now, find when relative velocity of A with respect to B. I want to know which is equals to how much it is. Relative velocity of A with respect to B. What will come, guys? VA minus VB. Is it
VB.
right? VB. So VA is what? Minus 30 minus of VB is 10 plus 10. So which is equals to minus 30 minus 10. So which is equals to how much, guys? All of you. Minus 40 meter per second. So relative velocity of A with respect to B. So who is seeing here? Who is our observer? Observer is B. Clear? Any doubt or Pradosha in this? Sai Gardik, Murali, understood?
Yes, sir.
Yeah. So please, any doubt, anyone can respond. Essentially, what happened? Network issues always like this means what is the use? So this is what. Any doubt, guys? Clear?
Yes, sir.
Yeah. So now onwards, problems will be little complicated. We have to observe very carefully. Now you see next question. Observe question number 3. Very simple, very easy actually. So no need to worry. Just observe. So one person is standing on the ground. One person is standing on the ground. Let me take is the person. I don't know. So that is why, or else you can name it as a B. So what is the person name? Everybody? Person name is B. So he is on the ground. So with respect to the ground, what is the velocity of him? Everybody? With respect to the ground, what is the velocity of him?
0 meter.
Yes, 0. Clear, everybody? So I will say with velocity of B with respect to ground, which is equals to what? VBG equals to, everybody, please respond. VBG is equals to how much, guys?
0.
0. Is it clear, everybody? Velocity of B
Yes,
with
sir.
respect to ground is equals to 0 meter per second. Now, he is observing a person who is traveling in the trolley. See that. Be very careful. He is observing a person A who is traveling in a trolley. Now, trolley is traveling 10 meter per second. Now, tell me, trolley is traveling 10 meter per second with respect to whom? Trolley. Yes, please. Trolley is traveling 10 meter per second with respect to whom? All of you. With respect to ground. That is what it is. Are you clear, everybody? So velocity of trolley with respect to ground, how much, Rudreshwar? 10 meter per second. Clear? And I'll say the person's speed with respect to trolley is 3 meter per second. Means in the sense of what? Velocity of A with respect to trolley, which is equals to how much? Everybody, please
A minus
3
B.
meter.
Yeah, 3 meter per second. Is it okay, Pradosh? Understood?
Yes, sir.
Yes? All of you?
Yes, sir.
Yeah. So now
Yes, sir.
observe very carefully. Now observe very carefully. We want to find it. Oh, sorry. Let me take. It is okay. If you take 3 also, doesn't matter. Now, shall we find it now? So observe very carefully, all of you. Now, I want to know velocity of A with respect to B. I want to know relative velocity of A with respect to B. So what is the formula will come? All of you. Velocity of A with respect to B, which is equals to what will come?
13
Everybody.
meter per second.
Yeah,
Velocity.
relative velocity of A with respect to B means what will come? Relative velocity of A minus, sorry, velocity of A minus velocity of B. Is it yes or no, guys? Yes, please.
Yes, sir.
Yeah,
Sir.
but have you noticed it? We know velocity of A with respect to trolley or with respect to ground? With respect to ground.
Ground.
Ground. No, with respect to trolley. But is it? Do you know velocity of A with respect to trolley? Everybody. Velocity of A with respect to trolley, we know that 3 meter per second. But what is the velocity of A with respect to ground? You know or don't know?
13 meter.
Don't know. So
No.
now you tell me if you are finding velocity of relative velocity of A with respect to ground, with respect to B, are you seeing the trolley or a person alone? Only we are seeing what? Person alone. Understanding? So we need to know velocity of A, relative velocity of A with respect to B is equals to velocity of A with respect to ground minus velocity of B with respect to what? Everybody?
Ground.
Ground. So now, velocity of A with respect to ground, we don't know. So let it be V of AG, I'll write it. Velocity of B with respect to ground, how much? All of you?
0.
0. Now, I don't know velocity of A with respect to ground. So you observe very carefully. I want to find velocity of A with respect to ground. So can you tell me velocity of A with respect to trolley, which is equals to what is the formula? Anybody can tell me? What will come? Velocity of A with respect to trolley. What will come? Everybody, please respond. Velocity of A with respect to ground minus velocity of a trolley with respect to ground. Is it yes or no, Pradosh? Yes or no? Yes?
Yes, sir.
Please respond. Now we know velocity of A with respect to trolley. How much it is? 3 equals to velocity of A with respect to ground minus velocity of T with respect to ground. How much?
10.
All of you. 10. Now this 10 will come this side. What will become? Velocity of A with respect to ground is equals to 3 plus 10.
13.
Which is equals to how much, guys? 13 meter per second.
13 meter
That's
per
all. So here if I substitute, so 13 meter per second. So with respect to B, what is the relative velocity of A? Everybody, what is the relative velocity of A? All of you.
13 meter.
13 meter per second. Understand, Ara? Pradashan? Rudresha?
Sir.
That is
Yes, sir.
very, very important. Are you clear now? Understand, everybody? So now,
Yes,
from
sir.
this we should understand. Now, if you are traveling in a bus, you are having, suppose bus is traveling 60 kilometer per hour. So now you tell me, you are having a velocity, suppose your velocity is 20 meter per second. Now your velocity is with respect to ground or with respect to bus? If you are inside a bus. If you are inside
Bus.
a bus, your
Respect to
velocity
bus.
is with respect to bus. If you want to find your velocity with respect to ground, then what we have to do? We have to find velocity of understanding a person with respect to bus. Next, here what is happening? A bus velocity with respect to ground. So this is the formula for finding velocity of a person with respect to bus is equals to velocity of a person with respect to ground minus velocity of a bus with respect to ground. Is it okay, guys? All of you understood?
Yes, sir.
Yes, that is what.
Yes, sir.
So that is very important. Next question. Question number 4. This question understood till here. Just think it and do it. Meeting is going to end. Join back. Then from there I will continue. Hope you all understood. I'm expecting. So if you have any doubt, you can kindly ask me. Samayan Manya, Sai Gardik, Laksha understood Laksha?
Yes, sir.
Okay. Complete it fast. Meeting is going to end. Join back. I'll send you so that we'll continue from there. Okay.